Hello Titans, this is Mr. Sturts. We are now in Chapter 7. The first section is adding and subtracting polynomials. So open up your student journal or wherever you take notes and we'll get started. In this section we have quite a few vocab words, so take a couple minutes, write these down in your student journal so we have all of these definitions. These are going to be very important throughout this entire chapter. Okay, and we'll cover each one of these vocab words as we move through this video. Alright, we're going to start by finding the degree of each monomial. Okay, and a monomial means one. We just have one term. The degree of a monomial is the sum, so we're going to add the exponents of each of our variables. Okay, so for A, we have 5x squared. Well, the only exponent we see there on a variable is the 2. So the degree of the first monomial is just 2. Okay, if we look at part B, we have an x and a y. We need to add the exponents of both of those variables. We know if we don't see a variable on the x, we know it's to the first power. So if we have 1 plus 3, our degree of this monomial is 4. For C, we have an x and a y again. We're just adding our exponents. Okay, so we have 3 plus 3. We get a degree of 6. And then on D, we don't see any variables. We don't see any exponents. So what we have for the degree there is just 0. Okay, so the degree of a monomial is when we add together the exponents of our variables. Alright, moving on to our core concept. A lot of good stuff in here. Okay, look at all these vocab words we're going to cover. So what a polynomial is, it's a monomial or a sum of monomials, so it could be more than one term. Each monomial is what we call a term. So if we see 5x right there for that binomial and 2, those are two separate terms. A polynomial with 2 terms is a binomial. A polynomial with 3 terms is what we call a trinomial, where there's 3 separate terms. Now, the degree of a polynomial is different than the degree of a monomial. Okay, what the degree of a polynomial is it's the greatest degree of the term, so it's the highest exponent is what we're looking for. A polynomial in one variable is in standard form when the exponents from left to right, when they're the biggest on the left, smallest on the right. So we're going to rewrite these in standard form. And then when we have the coefficient of the first term is what we call the leading coefficient, and that's the number out front of the highest exponent. Alright, let's do an example here. So they say first write it in standard form. Okay, so what we know is we need the highest exponent first, and then we're going to go from greatest to least as we go. So we see that x to the third, keep the negative with it. Okay, that's attached. Negative x to the third. We're going to write that first. Then we're going to look for an x squared. Well, we don't have an x squared. So we're going to move on to that 15x, so plus 15x, and then plus 3. Okay, this is in standard form because the highest exponent is to the left, and we go down from left to right. Now it says identify the degree. Now remember, degree of a polynomial is a little different than a monomial. We just look for the highest exponent. Okay, we see our highest exponent here is a third, so our degree is going to be 3. And the leading coefficient, that's the number out front of our highest exponent, of our greatest exponent. So it's the number out front in standard form we see is a negative 1. Okay, so our leading coefficient is going to be negative 1. So we have 3 things there. We wrote it in standard form, found the degree, which is the highest exponent, and the leading coefficient is the number out front of basically our degree. Okay, a couple more examples here. Write them in standard form. Well, let's look at A. There's only one term, so that's what we call a monomial, so we can't really rewrite it. The degree, highest exponent, we see the degree is 4. And then the leading coefficient, actually they don't even ask us for the leading coefficient here. If they did, it would be a negative 3. And then it says classify each by the number of terms. One term, we call that a monomial. Mono meaning one, monomial. Alright, B, write it in standard form. Okay, so standard form, remember exponents from greatest to least, so we're going to put the 5x squared up first, and then minus x, and plus 4. Make sure we keep those negatives with our variables. Okay, that's going to be a little tricky there. Identify the degree. Well, squared is our highest exponent, so our degree is going to be 2. And it's a trinomial, because there are 3 terms. Trinomial. And the last one here, write it in standard form. So we only have 2 terms, is what we call a binomial. We see q to the 5th power, so we're going to write that first. And then we're going to go down from there. Well, the next highest is the first exponent. Okay, so we're going to write 8q. Now, identify the degree. See, the highest exponent is 5, so our degree is 5. And classify each polynomial by the number of terms. We see there's 2, so it's what we call a binomial. Alright, find the sum of these polynomials. Okay, we got a lot of numbers here. The big thing is we got to group things together so we can combine like terms. Okay, the first method we're going to talk about is the horizontal method, and this is probably the method we're going to use the most. What we need to do is we're going to underline our like terms. So we go through and we see 2x to the third. Let's put one line under that. We look on the other one, we got to find the x to the third. We see one here, so we're going to have one line under that. Now let's go to the x squareds. We see, and we'll go ahead and put 2 lines under the x squareds. 2 lines under the x squared. Remember, we can only combine like terms. We're only going to add like terms. We go to the x. We see an x. Let's put 3 under that one. And we don't have an x in our second polynomial there, so we don't see any there. Now we have a constant. Let's put 4 lines under that one. So what we're going to do is we're going to combine like terms. Let's go to the single underlines. If we have 2x to the third and we have another 1x to the third, let's combine them so we get a 3x to the third. Okay, and in class we're going to use our algebra tiles to help us kind of understand this. Now, negative 5x squared, if we look for the 2 underlines, we see 2x squared. If we have negative 5 plus 2, we're going to have a minus 3x squared. And then we go to our third underlines. We only have 1, that's our x, so just plus x. And then our constant, minus 1. Okay, so we're just combining like terms. And all we have to do is find the sum, and there's our answer. Okay, let's try part B here. Let's give ourselves some more room. For part B, let's use the vertical alignment here for part B. Okay, and you can use whatever way works best for you. If we line them up vertically, we have our 3x squared plus x minus 6. We're just rewriting it here. Now what we need to do is we need to line up our like terms. So we see the x squared. We're going to put the x squared right underneath the 3x squared. We're going to put the 4x right underneath the x. And we're going to put the plus 10 right underneath our constant. Okay, so we're just lining up our terms. Now we're just going to add straight down. 3x squared plus 1x squared is a 4x squared. 1x plus 4x is a 5x. Negative 6 plus 10, well, we get a positive 4. Okay, so this is the vertical method. You do have to rewrite it in this method. It is nice because it lines up your like terms, but sometimes it's more work rewriting it. So use whatever method you like the best. Alright, now we got to find the difference. Okay, that means subtraction. Now the one key thing that I want us to do with subtraction, I think it'll help us, we're going to turn this into an addition problem. And when we do that, we need to change this subtraction to a plus, and we need to change the sign of every single term in that second polynomial. So if it was a minus, we're going to change it to a plus. If it was a plus, we're going to change it to a minus. If it was a minus, we'll change it to a plus. Okay, again, this is optional. I recommend it. That'll help us with our signs. Now let's use our horizontal method. So we're going to go ahead. Let's start with our n squareds. One underline. You see our n squareds over here. One underline. Now we look for the n's. We don't have any on the left side, but we have a negative 2n over here, so 2 underlines. And then our constant, let's put 3 underlines there. Now combine like terms. So we have 4n squared plus 2n squared. We're going to get a 6n squared. We go to the n's. We see we have a minus 2n over here. Don't have any on the left. And then 5 plus 4. We get a 9. Okay, so really subtraction, the difference is we're just turning it into an addition problem. So really the same thing. So let's go again on this second one. Change the subtraction to addition and change the sign of each term. And let's go horizontal method again. So 1 underline for the x squareds, 2 underlines for the x's, and 3 underlines for the constant. And combine like terms. So if we have a 4x squared plus a negative 3x squared, so we're really subtracting, we're left with just a single x squared, just a 1x squared. Negative 3x plus x, we're going to have a negative 2x. And then 5 plus 8, well, we're going to have a 13. Okay, and those are in standard form because the exponents are decreasing from left to right, and we have our answer. All right, now that you have your notes done, turn to page 207. Let's try these 4 problems. You should be able to complete these since we kind of talked about them in class a little bit and after this video. So have these 4 done, bring them tomorrow to class, and we'll see you tomorrow. Have a great night.